What's going on, everybody? Today we're going to be talking about polar coordinates, and more specifically we're going to be focusing on these three expressions right here for converting between Cartesian coordinates and polar coordinates. Let's start off by focusing on these two expressions right here. Now if we draw our x and y axes right here, so we're going to start off by talking about the Cartesian coordinate system. Let's say we have some point P here, and point P has a is given by, right, a x and y coordinate. I'm going to go ahead and draw a line connecting the origin to the point P. I'm also going to make a little triangle out of this. Now let's go ahead and assign some lengths to each of these bases of the triangle. What is the length of this base of the triangle? Well, that's just going to have a length of x, because we travel a horizontal distance of x to get to the point P. And similarly, we travel a vertical distance of y to get to the point P. Now in polar coordinates, we don't have x and y, we have r and theta. Let's go ahead and look at what the definition of those is. Okay, so starting off with r. R is the distance between the origin and the point, which in our case is P. And because r is a distance, r always has to be positive. Now let's look at what the definition of theta is. Theta is the, first of all, let's go ahead and label what r is right here. Well, this line is what connects the origin to the point P, so we're going to go ahead and label that r. Theta is this angle right here. And so it is the angle of rotation from the x-axis to the point P, and it goes in the counterclockwise direction, so it has to go in this direction. Now, using this information, we want to find some relationship between the Cartesian coordinate system and the polar coordinate system. And we can do that using this triangle that we made here. What are we going to use? You might have guessed it, trig functions. So let's start off with sine of theta. So sine of theta is given by the opposite leg of the triangle over the hypotenuse. So that's going to be y over r. Let's go ahead and solve for y. Y equals r sine of theta. Switching over to cosine of theta, that is given by the adjacent leg of the triangle over the hypotenuse, which is x over r. Go ahead and solve for x. We get x equals r cosine of theta. And look at what we have here. We have these two guys. So that's where these two expressions come from. Now let's focus in on this relationship here. There's two different ways you could think about this. The first way is thinking of this as the distance squared. What do I mean by that? Well, the distance between 2 points is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. All this is under a square root. Now for us, we are trying to find the distance from the origin to some point that has an xy coordinate. What does that mean? We know what the coordinates of x1 and y1 is. That's the origin, so that's going to be 0, 0. So we know that x1 comma y1 is 0, 0 for when we're trying to find the distance from the origin to some point. And so we can go ahead and simplify this. Distance equals the square root of x2 squared plus y2 squared. And x2 and y2 is really the coordinates of P. Now, we said that D represents the distance from the origin to the point. Well, in polar coordinates, that's precisely the definition of R. And so we can go ahead and make some substitutions here. We say r equals the square root. I'm just going to drop the subscript here, x squared plus y squared. So r equals the square root of x squared plus y squared. Square both sides, and we get r squared equals x squared plus y squared. And that is where this relationship comes from. What's the other way to think about this? Well, by using these two expressions that we just derived. X squared plus y squared equals, I'm going to go ahead and substitute x and y in. So that's going to be r squared cosine squared of theta plus r squared sine squared of theta. And looking at these two terms right here, I see a common term, r squared. And so r squared, we factor that guy out, sine squared of theta plus cosine squared of theta. And if you remember, there is a trig identity which says sine squared plus cosine squared equals 1. And so simplifying this, we get r squared equals what we started with, x squared plus y squared. And that is where this relationship comes from. That's been it for this video. Thank you so much for watching. If you have any comments or suggestions, put them down below, and I'll catch you in the next one.